biosafety issues. And today the focus is on regulation, although we will have another introductory talk today on biosafety issues given by Mike Mendelsohn, who is the chair, or who was the chair of the OECD expert group on RNAi-based pesticides. And so this will also be, I think, be a good introduction to the issues relevant for the regulation. And after Mike's talk, we will hear two presentations by regulators, one of which is also given by Mike. The other one is given by Achim Gartmann, who will then talk about regulatory approaches in the EU. And then at the end, we will have two presentations on industry perspectives. And yeah, I think that's enough for the introduction. Mike, I would like to ask you to start your presentation. And please, if everybody mutes their microphones and shut off the...
Thanks, Anji. I'm going to go ahead and share my screen now. If you can't see my screen, please let me know. All right, so I'm going to go ahead and get started. So today I'd like to talk about key issues for RNAi pesticides identified in the OECD working document. That working document was published at the end of September, and just want to also mention appreciation for folks that are on the call today that contributed to that. Certainly Anji and Achim were critical in the development. Also Greg Watson, who is part of BIAC at OECD, significantly contributed. So I just want to give a shout out to the folks that helped make this happen. So in this talk, I'd like to kind of go over the background to the development of the document and some of the key conclusions that we came to. And on the first page of this presentation is a link to the document, and I hope you spend some time looking at it. Okay. Okay, some background on OECD. I think most of you are aware, but OECD stands in the U.S. for Organization for Economic Cooperation and Development. It's an intergovernmental organization in which representatives of 37 industrialized countries in North and South America, Europe and Asia and the Pacific region, as well as the European Commission, meet to coordinate and harmonize policies, discuss issues of mutual concern, and work together to respond to international problems. And so this effort was an OECD effort. So again, looking at the risk assessment for externally applied double-stranded RNA-based pesticides, or that produce RNAi, the question was asked, are the current approaches to environmental and human health risk assessment for conventional and biological pesticides and or genetic technologies applicable to the risk assessment of double-stranded RNA-based pesticides that act by gene silencing? Are additional data needed to be developed for these types of pesticides? So in 2015, OECD formed an ad hoc expert group on RNAi-based pesticides. So the background here on the working document, so this OECD effort to develop a broad set of recommendations relating to environmental risk assessment considerations for exogenously applied double-stranded RNA-based products. So these products are using double-stranded RNA, but they're applied exogenously, sprayed, baits, maybe injections into plants. The distinction here is that the focus was not using this technology in plants, genetically engineered plants, but rather spraying it directly onto the crop. It was developed by the OECD ad hoc expert group on RNAi-based pesticides, And where this fit into the OECD, it's a subgroup of the working group on pesticides. And the purpose of the expert group was to help member countries to harmonize the methods and approaches used to assess exogenously applied double-stranded based RNA products. Again, just to emphasize, it does not address issues related to the risk assessment of genetically modified crop plants, which incorporate the machinery to synthesize RNA molecules specifically directed against the pest species feeding on the crop. So the focus is not the genetically modified crop plants. So as part of this process, we organized a conference in 2019 on externally applied double-stranded RNA-based pesticide. And this conference helped support the working document. It was held in April of 2019. And the focus of the conference was on regulatory needs and aspects of risk assessment. And we provided at that time a draft of the working document to be considered as well. So there was numerous presentations, very helpful, as well as discussion. And we also had the background document available for folks to see. So this page here also has links. There's a dedicated web page relative to the conference, as far as programs, speakers, abstracts, presentation files. That's all available at this website here. We also published most of the proceedings, including participants' discussions in the Frontiers research topic, RNAi-based pesticides. And again, here's a link to that. So all the papers that came out of the conference that again supported this effort are available in this Frontiers research topic. Okay, so now I'm going to shift focus a little bit. That's the background of the development of the document. Now I'd like to talk a little bit about the conclusions that we reached. So double-stranded RNA molecules developed for topical application to crops for pest control was determined will be assessed by relevant government agencies using a similar set of considerations to those applied to chemical and biological pesticides. So the kind of the base is the considerations that are currently used for chemical and biological pesticides. And as part of that, the pesticide use pattern and application method require consideration. So those would be, how is it used? Is it sprayed? Is it injected? Is it a bait? Where is it applied? Greenhouse, outdoor, etc. So those impact the risk assessment. So they need to be considered, the pesticide use pattern and the application method. Additional issues need to be considered, such as the potential to silence genes with significant sequence identity with the target gene. So again, as far as additional considerations, the potential to silence genes that have significant sequence identity to the target gene in the intended pest, and also the fate of the RNA in the environment, treated crop or animal. Those are some additional considerations. Again, looking at some of the conclusions, exposure is expected to be limited because of low application rates in comparison to many conventional chemical pesticides, and the anticipated rapid degradation and dissipation of double-stranded RNA in the environment. The potential for exposure of non-target organisms, as well as the responsiveness to environmental RNA, are the first parameters to consider in the risk assessment. So the potential for exposure, as well as the responsiveness to environmental RNAi of the non-target organism, are the first parameters to consider in the risk assessment. This is an important point. Sequence information alone should not and cannot be used as a standalone predictor of off-target effects. So what that means is if you have a match in a non-target organism of the sequence in the target gene of the target organism, that should not and cannot be used as a standalone predictor of off-target effects. There are other factors that impact the ability of the RNAi to silence the gene. So just because you have a match doesn't mean that there's going to be a problem. Bioinformatics can inform the selection and prioritization of non-target species for toxicity and effects testing. So we can use the bioinformatics to help select and prioritize the species that are tested. Now, an important point to mention here is that bioinformatics can be augmented, supported by an empirical approach to introduce, this is really the host range testing to see how related organisms to the target pest are impacted by the double-stranded RNA. So if it's, again, that is to perfectly, to take the dsRNA and expose it to a range of other organisms, starting with close relatives and then moving outwards to see how more phylogenetically distant organisms respond. So again, this is a bioassay to see how far the target, how far it goes as far as the impact to closely related species and then moving outwards. So using the bioinformatics together with the host range testing is a critical piece to get an idea of the range of effects with the double-stranded RNA. The bioinformatic, this empirical approach is not exactly a ecotoxicity study. It's really looking at the range. And then this helps also inform what studies should be looked at for ecotoxicity. Available evidence suggests that double-stranded RNAs have a long record of safe consumption by humans and other vertebrates. Nucleic acids are naturally occurring components of plant and animal-derived foods and feed and are routinely consumed by humans and animals. So that's an important point. I think everybody on the webinar realizes this, but people eat nucleic acids, animals eat nucleic acids every day. They're routinely consumed. There are significant physiological and biochemical barriers in humans and other vertebrates that limit the uptake and distribution of exogenous RNAs. So some of these include nucleases in the saliva, denature and depurination in the acid pH of the stomach, nucleases in the digestive tract, pancreatic secretions of bile salts and degradative enzymes, cellular membrane barriers, the polysaccharide coating of the intestinal epithelium, and intracellular degradation in endosomes and lysosomes. So the bottom line is that, again, there's significant physiological and biochemical barriers in humans and other vertebrates to exogenous RNAs. The barriers to double-stranded RNA uptake identified in mammals applies to other vertebrates. Also, responsiveness across invertebrate taxa to environmental dsRNA cannot currently be predicted. Okay, so barriers to uptake exist in vertebrates, and but for invertebrate taxa, there's a variation in effect as far as the responsiveness cannot really be predicted. All right, so now I'm going to shift focus here a little bit to the formulation component. And this was a really important piece that we came to. Specific product formulations can be designed to overcome barriers to uptake for the target organism. So they're formulants, added things you can add to the mixture that can be designed to overcome barriers to make the product more efficacious, but also would cause additional considerations to be looked at. Special attention should be paid to how barriers to uptake are proposed to be overcome for target organisms. And the impact. So we want to look at the impact of formulation on environmental persistence of the double-stranded RNA, as well as to barriers to and uptake of the double-stranded RNA by the non-target organism. So we're looking at barriers and uptake, and how, if the formulation would impact this. So I think if it's designed to do that, to expand the maybe the range, or to have it be more effective in a invertebrate that it would not be expected to work, that needs to be considered in the risk assessment. Information in our studies on the impact, uptake, and environmental persistence that the formulation presents are important to characterize exposure to the double-stranded RNA. So the main thought here is, if it's being designed to do this, it needs to be considered. And I think also, as when the risk assessment is done, also these considerations need to be looked at, but particularly if the formulation is being designed to do this. So where specific formulations impact barriers to the uptake of the dsRNA, product-specific formulation toxicology, testing on organisms or test surrogates would help better characterize the potential for hazard. The necessity of such testing depends on the legal requirements in different OECD member countries, as well as the characterization of the product. So different countries have different requirements. Some countries require product-specific testing for everything. Other countries don't. Those countries that don't, such as the United States, when you have this situation, you may need to test the product-specific formulation against the non-targets because of the impact of the formulation, as we've mentioned. So this is another consideration. All right. Another point that we came across was that, or came to the conclusion of, was that protocols for addressing risk for these products require some revisions compared to how they are carried out for conventional pesticides. So if we're using the conventional or biological pesticides as the base, and we're using a lot of the studies that are designed for those types of products, we have to modify those studies because of how double-stranded RNA-based pesticides work. And they often take longer to display efficacy. So any evaluation needs to account for this time lag by extending the study observation period. So this is a consideration in the design of some of these studies for double-stranded RNA products, that any evaluation needs to account for a time lag by extending the study observation period. Another point, for organisms that have been demonstrated to be responsive to environmental RNA, consideration of life cycle studies, growth, development, and reproduction, and studies on other non-lethal effects could be considered. So again, looking at life cycle studies as part of the evaluation. Additionally, any evaluation of a double-stranded RNA-based pesticide should include monitoring for degradation of the double-stranded RNA over time. And I just want to mention, so those are some of the significant conclusions. The working document goes into a lot more detail, but I want to mention that the expert group expects to be beginning work on the working paper on human health risks for the application of these products in 2021. And I do want to mention that the current document that was published at the end of September does address some of the human health issues in the background section, but again, the focus was on environmental considerations. So with that, I guess I'm not sure if we take questions now. I'm going to go ahead and stop sharing my screen.
So, thank you, Mike, for this presentation. And I don't see any questions here in the chat. So I think we can continue, and I think your presentation is also a quite nice introduction into the evaluation and regulatory issues of dsRNA-based pesticides. So I think we should now proceed to the next speaker, to Achim Gartmann from the Federal Office of Consumer Protection and Food Safety in Germany. Are you ready, Achim?
Yes, I'm here. Thank you, Antje, for your kind introduction. The title of my talk is Authorization of RNAi plant protection products in the EU and current situation and outlook. What I'd like to present today is to give you a short overview of the principle and the authorization process of plant protection products in the EU. So from my perspective, what is new and which challenges for the current risk assessment and risk management of PPA, and describe the current situation in the EU, also from a regulatory perspective. So I would like to give one preliminary remark. I present the perspective of the BVL. So the information is not based on a survey or any coordinated position of the European Union or member states of the European Union. And the focus is on environmental considerations mainly. So I will not go too much in detail, but when I go in detail, it's related to environment. So when we are looking at the authorization process in the EU, we have a two-step approach. First, we have authorization of the active substance is assessed at EU level and gets an approval for at least 10 years. In a second step, we have a product authorization for containing one or more active substance. Company submits application, including risk assessment for national or zonal authorization. I will go more in detail for the zonal authorization later. And at the end, we have an authorization for a specific intended use. This means against a specific pest in a specific crop. For instance, aphids in wheat. So when we look on the approval of active substance, this approval process is under lead of the EU Commission. The risk assessment of the active substance will be done by EFSA and member states. And the active ingredients is not approvable when one of the following of criteria is fulfilled. It should not be an endocrine disruptor, should be a mutagenic, cancerogenic, or toxic for reproduction potential, and also substances which with a high potential for persistence, bioaccumulation, and toxicity are not approvable. For the zonal authorization of plant protection products, this authorization takes place on a national level. So we have in Europe 3 zones. You can see the 3 zones here: a southern zone, a central zone, and another southern zone. And you can see here the member states which belongs to which zone. I would not go in detail here. So we have within a zonal cooperation. So we have one reporting member states who assesses the application for all the member states of one of the 3 zones. For instance, when you have authorization in the central zone, Germany makes the reporting. So in this report is valid for all these brownish member states. Member states are bound on this authorization, and member states can consider national specificities and decide on specific risk management option. Reason for that is that often the agricultural conditions are different between member states. So for instance, for risk mitigation measures, different options in different member states are needed. What are the areas of concern for the authorization product, for the authorization of plant protection product? So first point, we have product chemistry. There we are looking on chemical identity, physical and chemical properties, analytical methods. Then we have a second major issue is efficiency and application. There we're looking how efficient works the product against the pests, and also application techniques plays here an important role. Then we have health. There we're looking for toxicology, residues in food and feed, maximum residue levels, and exposure of applicants and bystanders. And last but not least, we're looking at the environment, and therefore we're looking at the fate of the active substance and the metabolites, and also ecotoxicology. So now we're coming to the legal framework. Our legal framework defines very clearly the data requirements. We have at the top our regulation is C 1107 from 2009, and also we have other regulation which defines data requirements for the approval of the active substance and also for the authorization of plant protection products. We have a further regulation, the 546 2011, which is the implementing uniform principles for the evaluation authorization process. So therefore, we have rules how decision making at the end takes place. And additionally, we have noted test protocols from different OECD guidance and EFSA guidance documents. At the end of the story, we have a defined set of test parameters and endpoints which has to be tested and which has to be considered in the risk assessment. What is also in discussion is RNAi products like in the States considered as a biopesticide. But this category, biopesticide, does not exist in the EU regulation. We have other classes like low-risk products. They have to fulfill specific requirements, or also basic substances. These are substances not primarily intended as a crop protection product, but which could provide crop protection capabilities. So in both classes, we have only 24 substances authorized or approved. Then we have also botanicals, which are extracted from plants, or microorganisms, which are living organisms. So RNAi will not fit into one of these categories. So from our point of view, we will at the moment consider double-stranded RNA-based plant protection products as conventional active substances and plant protection products. Therefore, the whole data package is needed for authorization as active substance or later as plant protection, similar to chemical plant protection products. However, there might be a possibility. We have Article 77 in the 1107/2009, which allows us adopting data requirements for specific groups. Examples are, for instance, microorganisms, where we have a specific guidance document, also pheromones or straight chain lepidopteran pheromones, or also plant extract and botanicals. However, for double-stranded RNA-based products, such guidance documents are not available. And at the moment, there is no initiative on preparation of such guidance documents. That is the bad news. So in the next slide, I would like to go a little bit back also to GMOs and lessons learned from GMO, maybe which we can use also for the authorization process of plant protection products. So we have a history of safe use of RNAi silencing. Many GMOs using gene silencing mechanisms like glucanation of browning apples, a flavor tomato, or compositionally modified soya beans and alfalfa. Also virus-resistant papaya, squash, plums, potatoes, and beans, and also the spruce-resistant potato. The target of this metabolism, the target of these products is the metabolism of the plant, but none of them are authorized in the EU for cultivation. Some are not authorized or only for import. And we have another group of products with targets outside of the plant. The most important example is the MON 87411. The construct is a DV-SNF7. This is assessed by EFSA for import and processing, but we have no authorization at the moment. And we have also now in the pipeline these sprayable plant protection products. But there are some differences, but also similarities between GMOs and these double-stranded RNA-based products. So when we're looking at the NTOs, the exposure pathway might be different. In GMO, it might be by feeding of plant material or debris of plants, and by RNA also by feeding, or these can be directly sprayed or have other exposure route. Time of exposure might be also differently. By GMO, it's continuously. By plant protection progress will be limited. Application of double-stranded RNA is tissue for these. For the GMO's tissue, for the plant protection product will be in some way be formulated. And also degradation might be different. In the plant, we have a balance between the degradation and product in the plant and the rapid degradation in the environment. And for the plant protection product, it will be strongly depend on the formulation of the product. When we're looking at the construct, mode of action, and specificity, this might be very identical for those cases. In the authorization process of plant protection products, we're looking on different processes and routes of exposure in the environment. This is presented here for the cases environment. When we apply the product, we look at plant uptake, biological and chemical degradation processes, by absorption, desorption, by runoff, by drift, by photochemical degradation, and also then in consequences in input terrestrial non-target areas, surface water, and in leaching and groundwater or drainage, and also in water or sediment, and also volatilization and deposition to get these products in the atmosphere. However, in my personal view, when we're looking at the experience from GMOs, some of these areas need less attention, and maybe there might be a need for data requirements in the authorization However, this has already to be discussed. So why RNAi products might be useful? It's a new mode of action, and therefore it has also a high value for resistance management. It has also potential for environmental safe products. I think that was highlighted in the two webinars in the last 2 weeks. We are a high specificity, minor effects on NTOs. Therefore, we have low stability in the environment, and therefore, in consequence, a low environmental load in soil, surface, and groundwater could be expected. We have a low risk for vertebrates during existing physiological barriers. But what is completely unclear is the formulation of the product, and Mike has already highlighted in his presentation that formulation might play a big role, and that we have maybe formulation which to overcome physiological barriers, or also improve the stability in the environment. Therefore, a lot of data gaps must be filled. Indeed, so we have for the risk assessment and for the risk management a lot of challenges. One I highlighted already in the last slide. We have the formulation. These points, efficient application must be protected from degradation, possibly new approaches for stabilizing RNA, improving RNA efficiency, delivery uptake of intact RNA into cells might be improved. There are several methods in discussion. Polymeric nanoparticles like chitosan, or we heard also from Nima in the first webinar, like clay particles, liposomes, chemical modification, e.g. adding methyl groups on specific part of the RNA. But there might be many other. We have also challenges on adoption of risk assessment methods. This was also highlighted by Mike in his talk before. Going a little bit more in details, our methods are really working. Our models used for the risk assessment appropriate to model exposure in soil, surface, and groundwater. These models are designed to address these issues with chemicals. Also, adoption of ecotoxicological testing schemes, like Mike already addressed. The time of testing, and also the exposure routes. Is there oral application needed? Maybe the glass plate test is not sufficient. And also, what also discussed last webinar, do we need information to support the risk assessment, like bioinformatics? From a risk management point of view, we have also to discuss mechanisms of resistance evolution, and also if we need new risk mitigation measures, if we identify risks in the risk assessment. And third point, we have challenges for the procedural issues. This addresses product chemistry. So one question is that each difference in a sequence leads to a new active substance, or make it from the other way, when we have sequence differences but matches on the same binding sites. Are these identical active substances, or are they different? So we have no criteria for that at the moment. So we need criteria for identification of the product. We have no experience about purity. We have all double-stranded RNAs in the product the same sequence. how much variability in an RNAi sequence is acceptable in a product. So that is also still an open question. And also what we are looking at is if GMO microbial production system will be used, so inactivation of microorganisms might be guaranteed. When such production system will be used, we have three options. We have the purified double-stranded RNA, we have the double-stranded RNA plus the biomass treaters and spent fermentation medium, but microorganisms are inactivated, or we have the same, but the microorganism is not activated. So for the first and second approach, it can be authorized by PPP. When we are using the third approach, it is also additionally authorization for GMO needed, so that will also be taken in mind. The last point of my presentation, I will give a short overview about this current situation and discussions in the EU. So we have no double-stranded RNA-based plant protection product on the market. Nothing is authorized. We have no application for authorization yet. We have, in some member states, application for field trials. So we have, as highlighted before, some experience with GMO using RNAi silencing mechanism in the EU, but only for import and processing application. And therefore, we have no full environmental risk assessment for that product where we can learn from. There was, in the context of RNAi products, a lot of activities. So EFSA, the GMO unit, in the context of GMOs, has organized a very big workshop in June 2014. There was a literature review initiated with Olivier, who presented last webinar. Some issues made with colleagues. And yeah, it was also a topic on an EFSA conference, Science, Food and Society in 2018. A few member states start to address this topic, for instance, the Netherlands. So there was a tech report from COGAM in 2016 and 2018, which addressed RNAi products as sprayable plant protection product. We have this OECD workshop and this OECD document where Germany actively contributed by the organization by developing this document. However, my impression is that double-stranded RNA-based plant protection products are not on the agenda of most of the EU member states at the moment. And I'm not aware of any significant activity on EU COM level, EFSA, or member state level in this context. Yeah. However, the EU Commission have announced several new strategy documents. Maybe you have read them, Farm to Fork, Zero Emission and Biodiversity. And an important point in this document is that they will take additional action to reduce the overall use and risk of chemical pesticides by 50%, and the use of more hazard pesticide by 50% by 2030. And the second point, to reduce the use of and dependency on chemical pesticides in general, and the use of more hazardous pesticides in particular. So maybe this might be a chance for double-stranded RNA product to be one of these alternatives which are needed when we reduce use of chemical pesticide. but the potential of the double-stranded RNA-based pesticide has to be assessed. And what is important in my view is showing the decision makers the potential of double-stranded RNA-based plant protection products and provide the authorities with sufficient data on degradation processes, host specificity, and health issues to show that these products are less hazardous compared to chemical plant protection products. At the end, I will sum up my talk. Yes, it's a new class with new mode of action and possibly low environmental harm. Double-stranded RNA-based plant protection products are not actively pushed forward by the political and regulatory authorities in Europe at the moment. Data gaps has to be filled. More evidence on the potential should be provided. And the Green Deal, where all these new strategy papers are published, might be an opportunity to bring forward double-stranded RNA-based plant protection program. However, one open point at the end will be the acceptance by this new technology by the public. So thank you for your attention, and yeah, I'm still there to answer questions.
Yeah, thank you, Achim. There are now a few questions, I think one of which may be for both of you, Mike and Achim, and that is many expensive studies standardly require to demonstrate that cut-off criteria are not met. So do you anticipate that these will all be required for the sRNA products?
Well, it's hard to say at the moment. The situation at the moment is that you have to do this.
Yes, I am super busy. Like, I don't know, I just have no time whatsoever to do anything. It's crazy. It's, I don't know, I'm feeling a bit stressed because of all that. Yes, because it's a lot of interviews, meetings,
there is some disturbance.
webinars, I don't know, it's just like tomorrow I have someone new coming from my group,
Sorry, Christina Acevedo, can you please mute your mic?
But I have no time, so she's from Thailand.
Thank you.
Yes, this has to be looked at. From my personal perspective, I would say yes, there is a lot of space to ease the requirements, but this has to be discussed with other member states and the Commission and EFSA, and there has to be a EU-wide decision how to deal with this aspect. But at the moment, I think you should give anyhow a good evidence in your problem formulation. Why do you think that these experiments are not needed? And maybe then there would be a possibility to ease the requirements. But I think we have to look at this on a case-by-case basis.
You want to add anything, Mike?
Yeah, I'll try to address it in my talk. I think it'd be, yeah.
Okay, then there is another question for Achim. What would be the anticipated timeline for the development of an EU guidance document for RNAi biocontrol once it is initiated?
Yes. I have no clue. It is very difficult to estimate or how long it will take. It depends from a lot of factors. It depends on public or political pressure, how many resources will be invested to develop such guidance documents. It depends also on other issues, on what is also to be done in parallel. So it's not an easy process. We have to come to a harmonized decision in the EU. And from experiences with other documents, I would say it would take several years.
Okay, another question also here regarding the EU. If data requirements for chemical pesticides apply in the EU for the dsRNA products, would it be possible to use the products in organic farming?
This is not a matter of the authorization process of plant protection products. This is more on the regulations which plant protection strategies are allowed in organic farming. So this has to be regulated in the organic farming regulations. So we are authorized in Europe plant protection products without saying this is for conventional farming, this is for organic farming. So we regulate it. Is there a health problem? Is there an environment problem? And this is fine. Then they are authorized. And so what can be used in organic farming is a matter of the regulations of the organic farming.
Okay, thank you, Achim. I think we should stop here and go on to the next talk. And this is again Mike Mendelson, who is not only the chair of the OECD expert group, but he is at the US EPA and at the Office of Pesticide Programs, and he will give an overview on the US regulatory approach for the sRNA pesticides. Okay, are you ready, Mike?
Okay, yeah. Can you see my screen now? The full screen?
Not yet.
Not yet, okay.
I see your screen.
Yeah, we see the screen, but not the presentation.
Not the presentation. Okay. Okay, let's see here.
Okay.
Okay, you see it now? Okay, good.
Go ahead.
All right. All right, so what I'd like to talk about now is kind of focus on the US regulatory considerations for commercialization of sprayed or externally applied double-stranded RNA-based pesticides. And so in the United States, at the Environmental Protection Agency, I'm chief of the Emerging Technologies branch. And our branch assesses the risk and also makes the decisions or recommends the decisions for some of these for these types of products. And just to give you some context, the Emerging Technologies branch is in the Biopesticides and Pollution Prevention Division within EPA's pesticide program. And so our group in the Biopesticides and Pollution Prevention Division, we look at what we call biochemical pesticides, like the pheromones and some of the natural substances. We also look at microbial pesticides such as BT, and we also have the emerging technologies in my branch, which include both genetic engineered microorganisms, what we call plant incorporated protectants or PIPs, which are a lot of the GMO crops. And then we also have synthetic peptides and the double-stranded RNA. In addition to the product-based groups in our division, we also have a branch that looks at pollution prevention, things such as integrated pest management and integrated vector management. So that's kind of the group that I work in and the context of where double-stranded RNA products are regulated in EPA. Okay. All right. So at EPA in the United States, the laws that we look at that are used, that we administer for these types of products, are the pesticide licensing law, which we call FIFRA, or the Federal Insecticide, Fungicide, and Rodenticide Act, and then also the law for pesticide residues in food, which is the Federal Food, Drug, and Cosmetic Act. There's a lot more than that, but one section of it deals with pesticide residues in food. These two laws have slightly different standards that we have to meet in order to allow for the licensing or registration of a pesticide, or for the residue of that pesticide to be present in food or feed. So for the licensing aspect or the registration, the standard is that there's no unreasonable adverse effects on human health and the environment. And that no unreasonable adverse effects also is a risk-benefit determination. Under the FFDCA, we have to come to the conclusion that there's a reasonable certainty of no harm from aggregate exposure to a pesticide chemical residue. That's strictly a risk criteria. So those are the kind of the context of how we have to make our decisions for pesticides and for double-stranded RNA products that are applied topically or exogenously. So some background at EPA for double-stranded RNA products. In January of 2014, we convened a EPA scientific advisory panel, a FIFRA scientific advisory panel. So under our pesticide licensing law, FIFRA, there's a provision for having outside experts give EPA advice. And so this is done through the FIFRA Scientific Advisory Panel. It's very, it has distinct requirements. We call it under FACA, the Federal Advisory Commission, advisory law in the United States. And so we convened a panel of these outside experts in January 2014, and the process is that we provide a background document and then ask them specific questions. It's a public meeting where the public has input, and these experts then provide their expert opinion to us in a report after the meeting. And so this 2014 meeting of these outside experts providing feedback and guidance to EPA addressed both RNAi and plant incorporated protectants, similar to, well, like the Monsanto now Bayer's product MON 87411, which is now commercialized or we've approved in the United States with DV-SNF7, which targets the corn rootworm, as well as, besides looking at plant incorporated protectants, this also looked at exogenously applied RNA pesticides and provided input to EPA. We also convened a specific meeting of the FIFRA Scientific Advisory Panel in 2016 to look at human health and ecological risk assessments for SmartStax Pro, which is the MON 87411 product. that includes an RNAi PIP for corn rootworm control. So we had a 2014 more general meeting of the SAP to give guidance for, both in GMO crops and also exogenously applied. And then in 2016, it was specific to this product that we were evaluating. In the 2016 meeting, the meeting was to obtain the panel's scientific opinion and peer review of our human health and the environmental risk assessment, and to also consider conclusions and recommendations from the earlier meeting in 2014. So those were helpful to us in evaluating the MON 87411, as well as developing our program for the exogenously applied products. And I want to mention we also participated in the OECD working document, Considerations for Environmental Risk Assessment of Application of Sprayed or Exogenously Applied Double-Stranded RNA-Based Pesticides, and that's also very helpful to us as well. So these are some background meetings and input that EPA received that really have been instrumental and helpful in our process. So I want to talk a little bit about what's the basis that EPA uses for these types of products. Similar to what was mentioned for the OECD document, double-stranded RNA molecules developed for topical application are assessed by EPA using a similar set of considerations to those applied to biochemical pesticides. So EPA actually has specific data requirements and guidelines in place for what we call biochemical pesticides. These are naturally occurring or similar to naturally occurring materials that act with a non-toxic mode of action towards a target pest. An example would be lepidopteran pheromones or coleopteran pheromones, things of this nature. And so repellents that are natural are also considered biochemical pesticides. Now, the double-stranded RNA that are being applied exogenously are not exactly biochemical pesticides. They're not really, but we are using the biochemical pesticide requirements and guidance documents as the basis. Another thing that's important to mention in EPA's data requirements is that there's a provision for data waivers. So if the requirement, one can satisfy the requirement by doing a study or by providing adequate rationale to satisfy, or information to satisfy that requirement. So that's kind of in addition to having data submitted, oftentimes applicants will submit waiver requests for studies that are not considered appropriate for their particular product. I also want to mention as far as the timing. So if I can go back here. So under FIFRA, this is our pesticide law, there was an amendment to the FIFRA called the Pesticide Registration Information Act. No, pesticide, I can't remember what PREA stands for, but PREA is our fee tag on to the law that requires it for multiple types of actions, such as to obtain a pesticide registration or license, or to obtain approval to field test. The applicant has to pay a fee to offset some of the costs of doing our review, and EPA guarantees a time frame in which we will make a decision. There's no guarantee of a decision, what the decision will be, whether it's going to be yes or no, but the guarantee is that we're going to complete our review within a specific time frame. Now, there's variances on that as far as asking for extensions and extending the PREA date and that sort of thing, but the main thing is that there's a time frame and a fee that's involved. Now, for these types of products that are considered biochemical pesticides, it's about a 13-month action. So EPA typically would take 13 months to review that. If there's a scientific advisory panel that might be necessary, that could happen at times, not regularly, then that would extend that. But as far as the time frame, that's what we're looking at. Also, I just want to address the organic question here for EPA. Again, like Achim mentioned, for in the EU, in the United States, it's our Department of Agriculture which determines what's on the organic list, and so we're not. We don't make that decision at EPA. Our decision is whether to allow for the licensing of the product. Okay. So again, as with other pesticides, we're basing the requirements for double-stranded RNA on our biochemical pesticide data requirements. And here's the link. If you can click here and you can see in detail what's required for a biochemical pesticide. But again, I want to mention that there's this provision for waivers if appropriate rationale are put forth. Maybe not everything that's required for a biochemical pesticide. And again, some of the considerations mentioned by the scientific advisory panel and also in the OECD environmental considerations document would be looked at. Additional issues need to be considered for these types of products, such as the potential to silence genes with significant sequence identity with the target gene in the intended pest and the fate in the environment. So these are some, again, additional considerations that are not spelled out in the biochemical pesticide guidelines or data requirements. So the types of data we look at for biochemical pesticide products are product characterization or product chemistry, how the product was manufactured, characteristics of the product, formulation. We look at human health considerations, environmental effects, which would include both impact to non-target organisms and environmental fate. And we also look at product performance. And it's important here on the product performance side, we look at product performance when we're looking at public health pests. So let's say something like mosquitoes, but not for all pests. Companies are required to have that data, but we don't evaluate it, or required to be submitted for many pests. But for public health pests, we require the submission of product performance data, and they have to meet certain standards. Again, as mentioned earlier, product formulations can be designed to overcome barriers to uptake for the target organism or to be more persistent in the environment, and special attention should be paid to formulations. EPA typically requires environmental studies on the active ingredient. Some of the fate would be with a typical end-use product, but for the most part, we are looking at product, we call it generic data on the active ingredient, or I think as Akka mentioned, the active substance, we call it active ingredient in the US. But where the formulation can impact the nature of the active substance in that it may be more persistent in the environment, it may be barriers to uptake are affected, then we might require some specific product-specific data in addition to the just on the active substance. Now we do require some product formulation-specific acute toxicity studies, but again, it depends. And in this, what I'm talking about is the other studies that are required for the active ingredient. And of course, the reason for this would be that these factors could impact the environmental and human health risk assessment. So we also, information under studies on the impact to uptake and environmental persistence mobility that the formulation presents are important to characterize the exposure to the double-stranded RNA. So again, product formulation for these types of products is an important consideration in the problem formulation for the risk assessment. Where specific product formulations impact barriers to an uptake of double-stranded RNA, product-specific formulation toxicology testing on organisms or test surrogates would help better characterize the potential for hazard. But if the product formulation is evaluated and found not to impact this, then for non-target organisms, we would again test mainly look at the active ingredient. But again, there's variations. Again, we would encourage folks to have pre-registration meetings with us to discuss these types of products ahead of time. In the US, we find these pre-application meetings very helpful in making sure that what's the data that's generated is what we need to make a decision and to do a risk assessment to support a decision. As mentioned earlier, sequence information alone should not and cannot be used as a standalone predictor of off-target effects, or what we're here talking about here are where a gene that is not targeted is affected. Bioinformatics can inform the selection and prioritization of non-target species testing for toxicity and effects testing. And it should be augmented by the empirical approach that we mentioned earlier, or I mentioned earlier in my earlier talk, that is to introduce a double-stranded RNA that's complementary to the target gene to a range of other organisms, starting with close relatives and then moving outwards to see how more phylogenetically distant organisms respond. So again, to get an idea of the range of this double-stranded RNA, in addition to sequence information, both in non-target organisms and humans, we should also look at this, I guess, this empirical approach, which is really the host range testing, to get an idea. And then based on that, we can determine what the appropriate organisms are to test. Again, available evidence suggests that double-stranded RNAs have a long record of safe consumption by humans and other vertebrates. We eat this every day. Nucleic acids are naturally occurring components of plant and animal-derived foods and feeds and are routinely consumed by humans and animals. In fact, for plants, there's an exemption for GMO plants and nucleic acids in GMO plants for human health under the FFDCA. Not in place at this time for the exogenously applied, but again, the point here is that nucleic acids are naturally occurring components of plant and animal-derived food and feeds. We eat them every day. There's significant physiological and biochemical barriers in humans and other vertebrates to limit the uptake of exogenous RNAs. The barriers to RNA identified in mammals likely applies to other vertebrates. Responsiveness across invertebrate taxa to environmental dsRNA cannot currently be predicted. Some are impacted, others are not. So bottom line here is that we don't expect there to be an impact to mammals or vertebrates. There may need to be some information provided, but specifically with some of the other vertebrates. But again, we don't expect there to be a problem here. And again, the basis for the dsRNA products that EPA is using, the framework, is the biochemical data requirements supplemented by these additional considerations that are specific to double-stranded RNA products. Again, as mentioned earlier, non-target organism toxicity study protocols would require some revision. So if we look at the guidelines that EPA has in place for biochemical pesticides, we look at some of the non-target organism studies, they need to be modified somewhat to account for the time lag by extending the study observation period. And if the organism has been demonstrated to be responsive to environmental RNA, then consideration of life cycle studies should be included. And then additionally, risk assessments for double-stranded RNA-based pesticides should include monitoring for degradation of the double-stranded RNA over time. So I just want to mention EPA typically will announce in the Federal Register when we receive a biochemical or a pesticide application for a new active ingredient. And so we have not at this time licensed a biochemical, a dsRNA topically applied product. We have registered the MON 87411, which is a GMO plant and not the subject of this webinar, but it does take some time for that process to take place, but there would be an announcement in the Federal Register at some point if we were to receive such an application, and that would be public, and there's a public comment period available for that. Okay, so that's all I have to share right now. I don't know if there are any questions.
Okay, thank you very much, Mike. And there are, let's see. To see if there are questions.
I see. Lauren has provided the description of PREA, Pesticide Registration Improvement Act. I just slipped my mind, and Greg too. Very good. Thank you very much.
Okay, I can only see one real question or more. What should monitoring be undertaken for degradation of dsRNA rather than a conventional lab degradation study? Oh.
Yeah, I think that'd be best discussed in like a pre-registration meeting with my staff and myself, as far as the parameters for looking at that. I think the idea in the non-target study is just to make sure it's still there over time. But if we're talking about the environmental degradation study, we have a number of requirements that we look at that are looked at. So I'm not sure if the question is getting to the non-target studies or to an environmental fate study.
Okay, then there is one question about if there is any evaluation of RNA-based pesticides going on in the US.
Yeah, so at this point, I can't say other than what we've said publicly. So the public process is we announce in the Federal Register when we receive an application, but that often takes several months. So no, we have not done that at this time. So we have not announced publicly that we received an application. So I can't really say whether we have or we haven't. Okay,
there's another question which is related to that, but asking whether any of these products has been, there has been an application and which there has been a delay or a rejection of an application of a dsRNA-based product. So
yeah, I guess I can't confirm or deny that at this point because we haven't said anything about it publicly one way or the other. So I think like other regulatory agencies have constraints on what we consider, confidential business information.
Right. That's confidential, right? Well, thank you very much. That's all. I think we can go on to the next presentation now, which will be given by Greg Watson from Bayer Crop Science. Thanks, Mike.
Hello, everyone. Greg Watson here. I'm just trying to get my screen up and running here. Antje, please let me know if you see the screen now.
Yes, I can see the screen, but not the full presentation. I have to open it.
You need to go to presentation mode, Greg. What we see now is the system that you use as a speaker, but you need to go to the presentation mode.
Yeah, I have to switch out here, guys. Give me a second.
I think you click down at the bottom where there's a little screen.
Is that better or still the same?
No, it's still the same. Yeah, sorry, you need to go down to the bottom of your screen and click the little screen symbol.
Display setting.
Yeah, I did that already, guys, but hold on. Let me just stop sharing.
When you're in that mode, if you hit display settings and say duplicate, it'll show the presentation mode on both screens.
Oh, my system's frozen. Sorry. It's a classic thing. It works during when you're planning it, but not when you're actually doing it. I'm gonna have to reboot and get back in. So I want to do that. If you guys want to go into Lauren's talk, that probably would be best, to be honest.
Yes. Is Lauren, are you ready to?
Lauren ready, and is Bruno ready to play the recording?
I'm uploading it. Yes.
Okay.
Let me share. Now I should start.
Good morning, and thank you for giving me this opportunity to present to you my regulatory perspective on RNAi products. After watching the presentations for these past couple of weeks, I thought I would share my thoughts on the promise and challenges of RNAi from an industry's regulatory point of view. Both the US and the EU are committed to moving to lower risk, more sustainable pesticides. So how do RNAi products fare compared to registration requirements? Let's start with efficacy, because without efficacy, you really don't have an active product. You know this better than I do, but RNAi interferes with the production of protein, but it can be any protein. And so the choice of that target protein really is important to have an effective product. The effect that you get from that protein depletion must control the pest, one way or another. To achieve that control, the target protein must have a short half-life so that the depletion of the protein due to the RNAi actually has a chance of having an effect. At the same time, and for the same reason, the target protein cannot be replenished so fast that a depletion really doesn't occur. Also, you cannot have other non-targeted proteins that have the same function that would just take up the slack from the depletion of your target. And finally, you want to have an RNA sequence that is specific to your target pest so that you have a very specific active substance product. Here's an example using Greenlight's GS2 product, which Ethan Barnes presented during the first webinar. As you can see from the graph on the left, while the control of the insects seems to be slower than the industry standards, you still have more live insects on the plants through day 7 than for the standard. The protection from damage, foliation of the plant, which is really the important part, as you can see from the graph or the picture on the right, is just as good. If you combine that with low application rates and application intervals of 7 to 10 days, then you have a product in GS2 that is really competitive with the industry standard. Let's look at the product chemistry for the technical. The active substance is made of naturally occurring bases, and the RNA is easily degraded by bacteria and other pathways in the environment unless the structure is modified or protected somehow. An RNA-based active substance is a large macromolecule. On the right-hand side, I have roughly to scale a DDT molecule compared to about 10 or 12 base pairs of dsRNA. A DDT molecule weighs in at about 354 grams per mole. 100 base pairs of dsRNA weigh in at about 66,000 grams per mole. And an active substance is likely to be hundreds of base pairs, so there's a large difference in scale. The manufacturing process makes it really difficult to have high purity dsRNA as a technical, and we are unlikely to reach the 95 to 99+% purity of conventional technicals. That is an issue to reach high enough concentrations needed in some of the GLP studies. Also, manufacturing has historically been too expensive for manufacturing use, at least for exogenously applied products. It is entirely possible that the COVID vaccines that are based on RNAi production are going to really increase the manufacturing capacity of RNAi products in general and may help change that cost. RNA is not soluble in many solvents commonly used in testing and formulation, and it becomes really viscous at really low concentrations, making it hard to work with and dose in studies. On the positive side, though, we do have a good recognized method, Quantigene, to analyze RNA in both standards and for GLP studies. The formulants, the inert ingredients in the formulated product, typically will do everything that they usually do in pesticide products. They will keep the dsRNA stable and homogeneous in the container for storage. They will help uniform application over the target crop. They will ensure techniques compatibility and make the product easy and safe to use by the end user. Some formulants could help in the activity or stability after application, and any formulation that significantly alters the profile of the dsRNA may invite further scrutiny from the regulatory authorities and likely additional studies. RNA has been part of the human, and mammalian, and vertebrate diet for millennia. We likely eat RNA from plant and animal sources daily, and some of that RNA has an exact sequence match to the human transcript. No evidence of deleterious effect due to that dietary input has been seen. It is so difficult to make RNAi infected mammals, actually, that pharmaceutical companies have had a hard time making an effective RNAi drug. It is too big to cross the skin barrier. It is degraded up to 99% when taken orally. And it even has a high and fast degradation via injection, which bypasses a lot of the barriers to uptake in mammals. Results of GLP studies published in the public literature on various RNA active substances, both endogenous and exogenous, also showed low toxicity to mammals. The VATPAs showed an LDL that was greater than the highest dose tested, both for the full RNA sequence and 21 mer siRNAs. DVCF7 had an OL at the highest dose tested as well, 100 mg per kg per day. And the BioDirect product also showed no toxicity to rats on a 28-day repeat dose study, as well as the acute tox 6-pack, the 28-day being at a max rate of 1,000 milligrams per kilogram per day. Moving on to the environmental fate, multiple presenters have shown at least some of these graphs during this webinar. All publicly available data shows that RNA from active substances degrade or dissipate in the environment in a matter of days. On the top, you have 3 degradation profiles in different soil types. On the bottom left, you have the degradation profile in pond water and sediment. And on the bottom right, you have a degradation profile of dsRNA in soybean after soybean application. All of those show a degradation profile that lasts just a matter of days. As mentioned earlier, different changes or different formulation ingredients could change the environmental fate and draw additional scrutiny from the regulators. So what should we make of any residues in the environment after application? Residues are going to be smaller RNA sequences, nucleotides, and nucleic acids. The US FDA considers nucleic acids to be generally recognized as safe. The EPA considers them to be exempt from the requirement of a tolerance, either as part of fully applied pesticide or otherwise applied pesticides, or as part of plant incorporated protectants. Some studies have been conducted after foliar application on residues on various crops. Here you have soybean, tomato, and potato. And those studies show that there is a rapid dissipation of the RNA on the crops, both in the edible parts and the non-edible parts. There are typically no detectable residues within 7 days. In the case of potato tubers, for example, where the pesticide, the RNA, was applied over the top of the plant, there were no residues. And there's no evidence of movement from the application site into the fruit of the tuber, even when the fruit was applied directly. So the RNA doesn't seem to penetrate into the fruit. In the case of the varroamide active BioDirect, there were residues in honey, but even then, a 28-day repeat dose oral tox study showed that the daily human intake would have had to be 475,000 times higher than the anticipated human exposure to reach the maximum dose tested in that study, which was itself non-toxic. On the ecotox end, as in the vertebrates toxicology end, there needs to be a sequence match in order to have a pathway to toxicity. But a sequence match does not indicate toxicity. In insects, there are many barriers to effect throughout the pathway, from degradation occurring in the saliva to hemolymph nucleases. Dr. Arpaio, last week, I think, discussed this in greater detail in this webinar, but Coleoptera, such as the ornamental potato beetle, this shown here, are the insect order most sensitive to RNAi. As such, you could consider them to be the low-hanging fruit. Many studies in the public domain show no evidence of toxicity to non-target organisms with really large margins of exposure. And pollinators, again, are rightfully a specific concern, and studies conducted with RNAi on pollinators also have shown very little to no effect. For example, DB-SNF7 had a margin of exposure that was greater than 4 to 25,000x, and an RNA that had a 100% sequence match to these, so similarly showed no adverse effect. Additional non-guideline bioinformatics and bioassay studies have been requested by regulatory authorities in support of the registration of RNAi active substances. Bioinformatics provide information on the sequence match, but we need to be careful that sequence match does not indicate toxicity by itself. The size of the sequence also matters a lot. The sweet spot seems to be 20 to 22 MERS, usually 21, depending on the species. The life stage of the insect may matter for the transcriptome also. And most importantly, the quality of the transcriptome is paramount in order to avoid false positives or false negatives. Related bioassays would confirm the relationship between sequence match and toxicity, but few species have standard protocols or guideline studies recognized by the regulators. Of those protocols, many have an exposure method that are not relevant to environmental exposure. For example, PPI injection, which bypasses a lot of the degradation processes. The number of species that both have a good transcriptome available and an accepted bioassay is fairly low. These issues can make it hard to relate any result to an environmental exposure or conditions, and it is difficult to find the right test to match the bioassay to the bioinformatics. In conclusion, RNAi products have a long history of safe use in ag, dating back to the 90s with Lagos tomatoes to DVSNF7 and other products. Mostly have been plant traits, and I'm not aware of any foliotype product registered yet. The data reviewed today show a very favorable regulatory profile, from high efficacy, low use rates, low human and mammalian tox, short half-life in the environment, high specificity, low non-target effects, and low environmental impact. Going back to my first slide, you could consider those RNAi products to be low-risk alternatives to conventional chemical pesticides and safe, efficient, and cost-effective alternatives to ensure sustainable food production. The history of use and data indicate that the existing regulatory model for biological products is appropriate for dsRNA products. And though not discussed much here, as new products are developed, industry regulators and users would benefit from more standardized requirements. The harmonization between countries would also help ensure a faster global registrations. And we would benefit as well from an EU process that better accounts for risk active substances like RNAi products.
Okay, thank you very much. And there are not really new questions. However, there is one question which has been raised before, which I think you may be able to answer. And that is, what are average numbers of applications of dsRNA products or biopesticides? Can you say anything about that? How many applications in the field are necessary?
Yeah, hi, this is Lauren, and I'm sorry for doing a recorded presentation. I'm feeling a little bit under the weather right now, so I didn't think I'd be able to talk for 15 minutes. The number of applications needed for an RNAi product to a conventional pesticide, I think, is really going to depend on the product itself. The goal really is to have a product that is competitive with the products that are out there. So you would want something that would be very similar to the conventional products. I think it's a general answer, but that's the best for this general.
Okay, thank you. There was another specific question. I don't know. What about, Letprona, your Letprona product? How many applications? Can you say anything about this?
Ethan Barnes had discussed that a little bit in the previous presentation. We're looking at a 7 to 10 day application interval and 2 to 4 applications, something like that over the course of the season.
Okay, thank you. I think there are no further specific questions right now, and I don't know if we can go on to the next presentation, whether Greg is ready now.
I hope so, Anja.
Okay.
My computer's at least working now. Is the screen okay?
No, don't see your screen.
All right, let me try again here. How about now?
Perfect.
Yeah, perfect. Thank you.
Yeah, sorry for that. It's difficult when you're running IT from your basement. So I'm Greg Watson. I work for Bayer Crop Science, and I've had the opportunity to address the AI plant audience a number of times. And that's kind of where I'd like to start the talk. Is just a reminder, well, a lot of these topics have actually been covered as we've gone through today's webinar. Laura just covered some of the safety information that we've shared, for example. So I would summarize, both from the human mammalian toxicity data that is available from DV7 as well as an exogenous intended for endogenous application double-strand RNA, as well as in the non-target organism testing that's done in the ecological field. A lot of the reasons that the biological model that is in existing regulatory pathways and paradigms is appropriate is that we're not seeing a hazard being demonstrated. So lack of hazard certainly means itself to, again, current regulatory process. And again, as we've said, and you hopefully have heard in other presentations, that when you're thinking about this in context, we've continually tried to present the fact that RNAi is certainly not new to agriculture. Again, there have been plant breeder selected through conventional breeding traits that we now know are underlying have RNAis as their mechanism. And if you think about, again, the way you go into a risk assessment process, evaluation through problem formulation of what are the exposure routes, what again, about from previous history with RNAs in agriculture, all lends itself to, again, a conclusion that the existing regulatory paradigm informed by problem formulation certainly should be adequate for regulation of double-strand RNA-based products. So what I'd like to do for the majority of the talk is, Mike gave a very excellent summary into the OECD working document, environmental fate and ecological assessment. So what I'd like to do is drill down into some specific sections I really would like to highlight to again expand on some of the things that Mike mentioned. And for full disclosure, Mike mentioned it earlier that I was a member of this RNA expert group, so can speak to some familiarity about its contents. While again, it's very clear that the document was written for exogenous application, I think there also it points to principles that would inform biotech risk assessment, and certainly those have been employed in some of the public available documents that can be found in how the reviews of DV7 have gone around the world. And again, I will repeat kind of the commercial a little bit that Mike mentioned, is that we're hopeful that the RNA expert group will begin work on a human health companion chapter. I think this is significant because this working document I certainly consider that the one we have published on the ecological is among best in class for how it covers the space. So the first part of the document I'd like to point to is this table. And I think from the presentations that we've heard today, you can kind of understand why this approach was taken. You can see a comparison here of the USC APA regulations and the data requirements that are from the biochemical requirements that Mike's mentioned earlier. So you then compare that to what is listed for data requirements in the European Union. And the thought process really for this was that this really gives you the boundaries of what the data requirements might be for an exogenous double-stranded RNA. And I think that's very important for developers of any technologies to kind of get an idea of where you are and what might need to be expected even before you take advantage of a pre-submission submission application. I think it is important, as Mike has already mentioned, to point out that the biochem regs are specific to the Biochemical and Pollution Prevention Division, part of EPA. So it would be in that specific branch as a review. I think that's excellent news, and it gives a very strong indicator, again, as we've said, that they're being treated similarly to biologically based products. And I think, again, as you've heard from the previous presentations and in looking at the history and a presentation that I gave in our last face-to-face meeting with the RNAi Planting Grid in Athens, is to look historically at a comparison between the EU and the EPA across, again, similar kinds of comparisons. And it's very clear that European Union, on average, has taken longer. 1.75x longer than the US to go through approval. And likely a lot of it is due to the data richness that you would expect for European Union products compared to US EPA. So I think, while having said that, and again, the lack of not having a discrete biopesticide category in the European Union is also a detriment to consideration of all biological-based products. There has been some movement in that there is a guidance document that is being considered right now to take a closer look at creating more of an official category, quote unquote, for microbial biopesticides. So I think that gives us some hope that you could eventually in the future have something similar happen for double-stranded RNA-based products. So the next part of the document I'd like to point to is this decision tree. And part of the reason I think this is so important is it touches on some of the things that we know from literature and that have been shown by the development of empirical data. And that is, that are specific to our knowledge about the RNAi pathway. Of course, every, part of when you're thinking about, and again, this table is really meant to guide a risk assessor and a regulatory authority, as well as a technology developer, to think about how they might do empirical testing, which we would still see as being a very important part of, again, the regulatory process. And so thinking about what your potential for exposure would be from your use pattern is the beginning step. And then the responsiveness to environmental RNA, again, has been talked about or mentioned by previous speakers, becomes an important component. If you have a non-responsive organism that is either through biochemical barriers or through its inherent RNAi pathway, then if that has a protection goal, you can again add that information to the risk assessment process. And again, I don't need to say anything more, I think, about the significant bioinformatic alignment that's been talked about in terms of how you would put it in context. So again, in this case, the decision tree helps you think about how it could inform empirical testing and choice of empirical testing models in conjunction with the responsiveness. And finally, just to highlight some of the conclusions from the document, again, I think these are, again, Mike did a good job of hitting those in his talk, but just like to reemphasize them, is that, again, like all crop protection products, if you look at the conclusion statement, look at how you would think about the use pattern and how it informs problem formulation, and a potential risk assessment is really important. We've had the question about degradation. Again, this conclusion document points to the Bt protein, biological-based materials, that testing protocol that has been utilized, and not necessarily the chemical testing, plant metabolism or soil metabolism work, for example, as the beginning point for looking at degradation. I think that's important. The conclusion documents also, in the document, also emphasizes the long history of safe use and exposure, as well as some significant barriers to distribution and vertebrates that, again, we've talked about. And so I think those are all very important things in terms of it sets guidance and the understanding, again, of what the base literature could be in this space. And finally, I think it also represents, as the formulation technologies have been talked about, there are mentions, of course, about how formulation could impact how you would think about the data needs. And certainly if that would be the case, if their formulations are intended, or technologies in formulation are intended to overcome barriers that exist to the RNA uptake and distribution, or to impact or prolong persistence. But deeper in the document, there actually are some very good guidance points that kind of give some insight into how you might think about taking steps to answer those questions. So don't have time to deal in that, but I think the formulation component is addressed very well in the document in terms of how it needs to be thought about in case-by-case basis. So I think what I would like to end with is that hopefully through this lack of hazard information, the content that's been expressed in terms of the what is described in this OECD document confirms what we've been advocating for the years, and that is the existing regulatory paradigm is certainly adequate for double-stranded RNA-based products. And I would encourage, again, that this document, from my view, is a significant development. It is, again, I consider it to be among the best in class in terms of how it thinks about the regulatory paradigm, where double-stranded RNA fits in it. So I encourage this community to leverage that in outreach and dialogue. And I would emphasize particularly, again, in Europe, because the basis of where I plan to is, but also because, frankly, it's a larger challenge in terms of the regulatory pathway and how it's going to be needed to be developed in the European Union. And so I tried to make this point, again, in Athens in the presentation, and so I just wanted to give kudos to the authors of the paper from Trends in Biotechnology that I've shown here. I think the papers like this and public dialogues and webinars like the one we're having today are very important as we start to try to elucidate what the regulatory pathway could be, again, with emphasis on the EU. So with that, that's all I prepared for today, and happy to join the discussion. Thank you.
Thank you, Greg.
Thank you, Greg. There are 2 or 3 questions now. One says, according to the talk given by Achim Gartmann, in Europe, applications for RNA-based pesticides will be treated as traditional pesticides. What are predictions from industry side? But I don't know that there are, I don't know if there are any specific predictions.
Well, so I'll try to take a run. I mean, I think I tried to allude to that in my presentation by talking about there is not a specific biopesticide category. So in the absence of having discrete category, then you have the uniform principles in 11907-2009 is really the only basis to start from. But again, that is also the base for a number of other historical biopesticides. And you have seen pathways, again, particularly that's why the dialogue on a category for the microbial biopesticides, that's so important, is that hopefully then you can at least see a way forward how data requirements could be informed by guidance documents that could be developed in the future. Hopefully that gives some insight. But without a doubt, Europe, in my personal opinion, and this is the true for any biologically based biopesticide right now, Europe has the largest data set compared to rest of OECD countries.
So then there is one question, is Bayer still investing in RNAi technologies? And I also have a question regarding that, because you showed this varroamide specific product, which you are developing. And my question would be, how is it regulated in the US? And also, how would it be regulated in the EU? Do you have any ideas about that?
So I'll try to take those in parts. Bayer certainly invested in the RNAi space. We certainly have platforms and research still in that space. And I would point out that also our large contribution to the published literature. I don't think there's been, there's not been any secret about, what the underlying risk assessment and data we've generated in that space when it's appropriate to go through the space. So I can speak in general about bee products. There is a possibility in the United States for bee product to be regulated by as a veterinary drug. That would be under the auspices of the Center of Veterinary Medicine that's part of FDA. But also EPA has regulated many bee products. To my knowledge, every product that has been aimed at management or control of varroamide in the US has been approved through EPA. So Europe's a little bit different. The opposite is true in Europe. It's called 1107 is called the Plant Protection Directive. So tells you that's probably not well, that would be regulated, right? So it would be likely in Europe that you'd be looking at a veterinary medicine, which by its very nature then tells you that the development of anything in the bee health space is complicated.
Okay, thank you. Well, I don't see any more specific questions, so I think we can open a more general discussion. And there was one question raised before regarding the low interest in Europe, and there was the question whether member states are not even aware of the RNAi technology. Any thoughts on that?
Well, it was my question related to a comment from a hacking presentation.
Yeah.
Okay.
I
know, but it's just a general question, of course, whether member states in Europe are not so aware of the technology, because they don't seem to do much regarding it, and so don't develop documents or anything like that, and we're not very active not in the OECD group, etc. So that's maybe.
So maybe I can answer, Antje. I think you're right. So I think it's not on the agenda at the moment of the member states. I think they are aware. Many of the European member states were on the OECD workshop. So therefore, they got a first idea what is in the pipeline and what is going on. And also some member states, like the Dutch colleagues, address this in some papers that is an upcoming issue. But what's still lacking is that there are any activities to proactively addressing this issue in a regulatory context discussing how to handle this in the future. That happens not. In my view, it's a matter of resources. It depends also on member states, the authorities, which are dealing with plant protection products have really different authorities. There are some member states like Austria, Germany, or the Netherlands, which have big authorities with a lot of employees. But when you're looking at smaller OECD, EU member states, they have only a few people to do so, and they kind of going forward with these issues. And yeah, and I think that's the situation at the moment. It will not actively pushed. So far, I know also EFSA is not actively discussing this issue. So yeah, I think yeah, it's not going forward at the moment.
Yeah, and I think also a big issue for the sRNA products are, as was mentioned repeatedly, is the issue of the formulations, because the environmental advantage of the sRNA is, of course, its fast degradation rate, but on the other hand, that's it acts against the successful pesticidal action, and therefore formulations are necessary. And of course, this counteracts then this environmental advantage to some degree. So for me, there is the question whether formulations are then compatible with low risk categorization of this type of products in certain regulatory environments, and also the question of the how much variability is acceptable in the sRNA products is, I think, an important question. How pure does it have to be? Is it with respect to a sequence identity, with respect to the length of the RNA, and all these are, I think, important questions to be clarified for the regulation and for the approval of a product.
So Anja, just to speak quickly about the short half-life, there are many active ingredients that actually have similar foliar half-lives as RNA that haven't, they've been effective. But I think what it does tell you then is that the application timing becomes important. And so in those systems where you have very good prediction systems or knowledge of when an organism is going to be a pest is going to be active, would give insight in terms of how to best time applications. So I think, and just a general comment, right? If you're a developer and you're thinking about where you go first in the world with an RNA product, you maybe not want to go to the toughest battle first. So I think it actually, and that for me, it's difficult for European regulators probably to prioritize something until they have something in front of them in this product category that's really meant for cultivation. So I think that's just, in some regards, the reality. But again, I think, that's just in general terms. Thanks.
Okay, thank you. Are there more views on the formulation issue?
Yeah, I would add that the half-life really is only part of the equation, and having a formulation that increases the half-life of a product that is not toxic isn't going to have that much of it. So if you have an RNAi sequence that is not toxic to human, it doesn't matter that much if the half-life is 2 days or if it's 2 weeks. There's still not going to be much toxicity.
That's true. That regards the half-life. On the other hand, the formulation also has some, has some special properties and maybe to some degree be toxic or.
And another part of the equation, I think, is that the sRNA products are designed to be very specific to a target pest. And the mammalian studies that have been published show really very little to really no toxicity in mammals in general, in humans either.
Yeah, and just to follow up on the specificity question, that's one of the challenges. Is if you've got, for example, the data set of a conventional pesticide, you know, as part of what your data need is, and we know that for development of that is in the tens of millions of dollars. You only have one pest because of the specificity of the mode of action. It's very difficult to find, you know, a market size that would support that. So I think that's part of some of the play you'll have in how the story tends to play out or will play out.
Yeah. Okay, I have also had some thoughts about Achim's categories, and I was wondering whether there's any overlap between these categories, like low-risk products or plant extracts, etc., and whether also the sRNA products might fulfill eventually the requirements for low-risk products.
Maybe I can answer. There are very strict requirements for low-risk products. One of these requirements is that we have no risk mitigation measures, or a product or an active substance should not have any risk mitigation measures to be a low-risk product. And I could not imagine, when we are looking at non-target effects, that this really happens. So I would say, when we go in details on the requirements to categorize a product as a low-risk product are very strict. And at the moment, I don't see that double-stranded plant protection products will fall in this kind of category.
Okay, thank you.
So when you're looking at substances which are falling low risk, it's active ingredients is beer or vinegar, such things. Also very, very basic issues also, which has some potential for pesticidal actions, but these are often not chemicals.
Okay, thank you. I don't see any further questions here. Jeremy, Bruno, do you have any specific questions?
Well, actually, there is something from Salvatore. There is a question from it's similar to what, but I have also a comment. For me, it was really impressive, clear and easy definition coming from FDA and from the OECD document, so that nucleic acid are safe. So very easy definition. It looks like that in Europe it's much more difficult to have such a very easy, I would say, definition, rather also very easy to understand and to accept definition. And I would say that can make really big difference between what it will be the approach of regulation of such new product in US and the approach of regulation of such new product in Europe. So I don't know, again, probably we need to speak and discuss and give more information about that. But in my view, it may happen that in the next future there will be a big difference in the regulation in between the EU and US regulation. So I don't know if you have some comment, if some of you have some comment on this.
So Bruno, the only thing I will add is there actually have been RNAs that have gone through in the beet health field approval in Europe. And in that case, there's very clear a decision not to establish the equivalent of a maximum residue level in those cases. And that was driven, frankly, by the lack, again, of uptake, distribution, and any, potential for hazard. So I think, there's a very clear, at least from one regulatory authority, a very clear statement that I think it means itself to the part of the dialogue. Thanks.
Thanks.
Maybe, Bruno, I would not say that the OECD document says that double-stranded RNA is per se safe. So I would say we identified areas where we say there is a lot of evidence available, where we can ease the requirements on risk assessment, but also we identified some areas like non-target organism specificity. We discuss this also in these 3 webinars, where we need more information or we need adaptation of the data requirements because of different exposure routes or the duration of test procedures. So I would not say it's black or white, it's somewhat gray. And yeah, also to the differences between the US and Europe or other parts in the world. So there's also a little bit a difference in the mentality of risk assessment in Europe compared to the US. So we have defined in our regulation other protection goals or the different protection goals in the formulation. We have protection goals with a precautionary principle and such issue in European regulation, which might made it more complex to come to a different risk assessment. So it's really a complex issue. I see, again, with these new strategy papers, which was also highlighted, we have opportunities to start the discussion in Europe again, make this topic more prominent, also to decision makers, to the Commission, and also to EFSA to go forward with that and start the discussion. The OECD document is already a good starting point, and I would say it might be also a task of this implanter network to support this discussion and give tipping points that the issue will go forward.
Bruno and Angie, I have a question. This is Mike Mendelson. I saw in the chat here that Venkata Amenia indicated that it says, the previous presentations mentioned that the higher concentrations at repeated treatment may cause some lethal effects in humans. Will there be any type of treatment or antidote available for humans if the accidental unwanted consumption of bulk amount of dsRNA pesticide happens? And so my question back is, can you provide the reference where you indicate that the higher concentrations at repeated treatment may cause some lethal effects in humans? I think that's very important if there is such a reference, if we could have that. I'm not aware of that at all.
Yeah, I'm also not aware, yeah. And the That's why I also didn't give past this question, because I was not aware that there was any report in previous presentations about that. So
Yeah,
yes, of course, such a reference would be very important if there is one.
yeah, and again, dietary route for sure. The lack of a hazard and any significant uptake is pretty well established from our point of view as well. And note that the study referenced for the biodirect active was fed at limit dose in the 28-day.
Yeah, there is an answer from Venkata. Mike, your microphone.
Okay, is that working now?
Yeah.
Okay, sorry. Yeah, so I see an answer here. Venkata provided that she's mentioning, or he's mentioned the DV-SNF7 in the 28-day repeat dose oral toxicity study on mammals. Again, I don't recall that there was a treatment-related effect there. So, so it wasn't in humans, and I don't think I have to go back and look at the study, but I don't think there was a treatment-related effect in the DV-SNF7 28-day study.
That's correct.
Yeah.
And I think that data has been published. It's one of the Petrick citations.
Okay, so
So
just to clarify here, then there have been no indications that higher concentrations of double-stranded RNA will cause effects in humans that we're aware of. So
That's
just
my,
to clarify that.
I'm not aware of any.
Yeah. Okay.
Thanks for getting back to us, Venkata. I appreciate it.
Okay.
Okay, that was very specific now. Are there any further points to discuss? Any more comments, or otherwise I think we may close the discussion unless there are urgent points.
Yeah, Anjit, this is Mike Mendelson. I just want to say that, we're excited about this technology at EPA as a reduced risk pesticide opportunity. Certainly there's special considerations that we have to look at, but the target specificity and the types of, there are a lot with the ability to provide new tools for growers with what we believe is a safer technology. Just to say that we're excited about it, and there are unique things we have to look at. It's not just a blank check. We have to consider the risks, but there's just great opportunity here, and we're excited about the future.
Yeah, I can also add something about the situation in Germany, at least. And from my experience in the last few weeks or months, I only also see that there may be a potential here, because there's a really big necessity in Germany and probably all over Europe to develop new types of pesticides, because there are very little products left, especially in the insecticidal sector. So there is really, I think, a need for this, and it also just depends on how people will accept this, especially as it has to do with nucleic acid, and people sometimes connect it with gene technology, especially if the dsRNA is produced in GM microorganisms and so on. So we have to see what happens here with acceptance, but there is really a big
Yeah, well, Anshi's good. I just want to say thank you for the opportunity to present from the industry side. And on the public acceptance, it's actually, you may be interested that a lot of the first vaccines targeted at COVID are actually based on mRNA. So we'll have to see how the public uptake and the understanding of the underlying mechanism there might help. Thank you.
So,
Okay, so thanks very much, Antje, for chairing this session, this webinar this afternoon. We've had now 3 webinars on this subject of RNAi pesticides and topical applications. I'd like to thank all the speakers who are involved in all 3 of the webinars. It's been a very useful series and a very interesting series. Also, I take some responsibility for organizing these, and it's the first time I've organized a program of webinars. So I would welcome any feedback or any comments from people on this series. This is the first time in iPlanter we have done this. I think, as Bruno will be saying in a minute, we are trying to get people in Europe excited about RNA interference because we see it as a very useful strategy for both plant improvement and crop protection. And so therefore we are going to develop a further program on this and try and use this to publicize this technology and its merits, as well as obviously look critically at some of the hazards that we've been talking about in these 3 webinars. So once again, thank you to all of the people who've been involved in these first 3 webinars. I've been very pleased with the talks and the quality of the presentations. I've also been very pleased that we've had people from all around the world joining. We've had over 100 people at each of the webinars and joining from all corners of the earth. So thank you very much to everybody for coming along and joining in. Now I hand over to Bruno, who I think is going to talk about the next program of webinars that we've got coming up. Have a look at your screen, and this is what he will be talking to. So over to you, Bruno.
yeah, thank you, Jeremy. I was sharing my screen. Do you see my screen now?
Yes, yes, I see it.
Just the list of webinars. As you said, we just ended the 3rd webinar, and we already planned, or we are already working on other practically 7 webinars, or at least 6 webinars on 6 different topics. These are the topics. So some already defined. So honey sweet RNA-based PPV resistant plants. So an example of a GM plant crop that is taking advantage of this technology, and we want to see that. Then we focus on fungal and pathogens. That will be the 9th of February. The insect probably is the 16th of February. And then communication strategy and RNA impact in agriculture. We are work on this. I want to anticipate, not sure it will happen, but we approach Mark Linas, that is a famous writer, that is famous for a book, A Seed of Science, and it looks like that he's expressed an interest to join us in this webinar. Let's see if this will be confirmed. More important will be the webinar that we are going to organize for March, the 4th of March. It will be a full-day webinar. We are working also with the help of the officers from the COST and from Horizon 2020. We want to have a full-day webinar addressed to stakeholders and policymakers. So we want to involve officers from the European Horizon 2020 program. So again, to show them that there is this technology and discuss with them this technology. And as much as possible, I don't know how far we will be able to have more people from also from the European Parliament, so member of the European Parliament. So we are already working on this program, and I think that will be really an important event. Then we consider the fact that the RNA can be used also to modify or to control plant development, so epigenetic development. We are working also, just not to say that the technology can be used only for pest diseases, for pest and disease control. Clearly, that is probably the most important area. But there is also this other possibility, and we will work on that. We will try to make a point on this technology, having 4 or 5 presentations. Then we will be more or less at the end of the action. So end of March, we will have a final conference. We hope maybe to have it hybrid, so some people in presence or some people and then all the other connected. We don't know what it will happen from the beginning of the year about maybe the buses and so on, so people can start to move, to travel again at least a little bit. If not, in any case, it will be at the same. So we will have again, we will try to summarize the activity done until now by giving space again to some of the most important speakers, and so to make a final point. And then there will be the end, that will be the final management committee meeting on the 27th of March, and it will be the end of the action. And in the meantime, we will see, we are starting also to discuss a little bit what can be the future of this network, and I really hope that we will find the opportunity to maintain and further develop this network, considering the fact that we are speaking of a technology that looks like it's having high perspective of development in EU and other countries. So I want just to anticipate this program, and I will keep you updated through emails, through email message, as soon as all this program will be defined and updated. And updated the web page with the link for the registration at each new event. And again, I want to thank everybody, all speakers, Antje for chairing the section, Jeremy for assisting us and chairing and helping in the organization, and all people that attended this today webinar. If you have just 1 second, and I can ask you to switch on your camera to the people that still is connected. I will take a photo. So just to have a nice photo of whole people that is connected. That is useful to also to share this information. So maybe there are other 2 persons, Pedros, Bessie, Pantaleo. I don't know if they are connected. If they can switch on the camera. Bessie, Pedros. Okay, so it's nice to have the full screen full of face. Let's wait for Bessie focusing a little bit. Okay. It looks nice, so I will take a picture. Okay. Great, done, perfect.
So this will be your new Christmas card, Bruno.
Yeah, sure. Thank you very much. Oh, okay, I see also nice friends here. Okay, well, it's for us almost late in the afternoon, so again, thanks a lot for your participation, and we'll be in contact, and I really hope to see you again virtually when we will have the next webinar in January. Goodbye.
Goodbye. Thank you.
Okay. Ciao. Bye-bye, everyone.
Bye.
Bye.